usually in terms of assessing buildings for embodied carbon, we mainly look at materials, but we can actually start looking at how specifying and the impact that building services have on the wider building is just as important. So just re-showing this graph, it's just finding that balance between operational energy, embodied carbon of the building systems themselves, as well as the impact that it has on the rest of the building. So quickly just putting all of those considerations into a case study to show you how we've actually thought about the influence on a particular development. This is 9 Wellington Place in Leeds, and we did look at a sealed versus a mixed mode comparison where the sealed was completely sealed, had no openable windows, all the ventilation heating cooling was operated internally, versus a mixed mode where this, again, it was still fixed windows, but it had openable louvered ventilation systems. So when looking at the building systems of how it would serve both of these options, we did the study in conjunction with Arup, who suggested that you could potentially use both systems, the same systems for both options. The only difference would be potentially the mixed mode would have less pressure, so therefore it would potentially last a bit longer because it's not having to work as hard versus the sealed version. So in terms of embodied carbon, we did see an upfront embodied carbon of 5%. Purely because of the additional materials involved with the openings, the additional metalworks and the louvers and such. And then how we mapped that against the operational energy versus including looking at 2 different decarbonisation factors for the grid. So you've got the bottom line here is your sealed version for the 2 different decarbonisation grid factors, and the yellow line is just a static just to show you the upfront and compare the payback of the 2 different options. So initially it was still showing that as much as the upfront of the mixed mode had a higher upfront carbon, it was still worth the payback over the life of a 30-year expected lifespan of the facade. We then revisited it, and this was quite early on in stage 2, and then as the project developed, they looked a bit more detail in more accurate estimations for the operational energy, and we revisited the study. We then estimated that because of the operational energy improvements, that the sealed version would actually work out better in the long run. So the client did actually go for a sealed version at that time. And then lastly, it's fair enough. It's all thinking about how you can lower embodied carbon of the systems up front, but it's how you then ensure that those units can be used in the future. So examples are, fan core unit housing. Can you repurpose them for future developments, whether that's in situ or elsewhere, depending on the type of refurbishments? Because obviously building services get replaced a bit more often than, say, some of the other elements. So it's trying to minimise the whole life embodied carbon of those ones.